So these are all the values that we've calculated for the circuit thus far. Okay, we changed the inductance value into an ohmic value for the inductor. Then we use the ohmic value for the inductor and the ohmic value for the resistor to get our impedance. And once we obtain the impedance, we use the impedance to get the total current for the circuit. Now that we have the total current for the circuit, we can do other things like calculate power. Now, this triangle is very important because the titles for each segment of the triangle are important for you to remember. The hypotenuse of the right triangle is called the apparent power, and that's the total power of the circuit. It's very important that you always keep it on the hypotenuse side. The reactive power is the power that comes from the inductor, and that always goes on the vertical line. And the true power is the power that comes from the resistor, and that always goes on the horizontal line. It's very important for you to keep track of where all these labels go on the triangle. You cannot switch the labels or your math is going to come out wrong in later calculations. All right? So we're going to go and calculate the true power, which is the power of, like I said, the resistor. And the power formula we're going to use is the power equals to the current square times the resistance of the resistor. All right? So let's go back and get our values. We know that the total current is 0.063 amps. So let me replace that. 0.063 amps, and we're squaring this, times the resistance of the resistor. Okay, so it's 60 ohms. So I'm going to replace that. This will give me my true power, which is the power of the resistor. So you put these values into the calculator and you get 0.063 squared times 60 ohms. And I get a value of 0.238 watts. Remember that the unit for power is watts. So this is my value for true power. So now you go to your power triangle, and this is where it goes. That is my true power for the circuit.